Okay guys, let's continue. Okay, so we had our feasible region. Now we need to find the quarters. It looks like we've got 0, 0. Looks like 0, 4. 6, 0. And 4, 2. Has our 4 possible points. So let's plug these all in. So that's 0, 0. Guess what? If we load on 0 medical kits and 0 water containers on our plane, we helped 0 people. Now remember our Y's, they're in thousands. Just keep that in mind. Everything's in thousands. That's 0, 4. If we decide medical kits are a waste, let's go all water. We help 40,000 people. Because it's in thousands. At 6, 0. If we decide water is a waste in a disaster for some reason, 6 times 6 plus 0 is 36,000. And then if we manage to balance it at 4,000 medical kits and 2,000 containers of water, 6 times 4 plus 10 times 2, it's 24 plus 20, which is 44,000. So the number of each item to be put on the plane in order to maximize the number of people helped wants to know the items. So we should put on, this is in thousands, 4,000 medical kits and 2,000 water containers. Maximizes the number of people helped. At 44,000. This is the idea of how a problem works, what kind of restrictions businesses have. So let's do one more. One that looks a little bit different because I talked about you could have an upper bound instead. Robin takes multivitamins each day in order to support a healthy immune system. Good for Robin. She wants at least 16 units of vitamin A, 5 units of vitamin B, and 20 units of vitamin C. Capsules costing 10 cents each contain 8 units of vitamin A, 1 unit of vitamin B, 2 units of vitamin C. Chewables costing 20 cents contain 2 units of vitamin A, 1 unit of vitamin B, and 7 units of vitamin C. How many of each of the capsules and tablets should Robin buy to minimize her daily costs? So here we're minimizing. We're minimizing her cost. Her cost function is 10 cents per capsule and 20 cents per chewable. I had trouble finding the words. Capsules cost 10 cents. 10x plus 20y, and we'll do this in cents. Okay, since capsules are our x and chewables are our y, let's talk about our equation for vitamin A. She needs capsules costing 10 cents, 8 units of vitamin A in that, 2 units of vitamin A in the chewables. So 8x plus 2y, and she wants at least 16 units. So greater than or equal to 16. She wants at least 5 units of vitamin B. And the vitamin B amounts are 1 unit of vitamin B and then 1 unit of vitamin B. So it looks like x plus y is greater than or equal to 5. And then vitamin C, she wants at least 20 units. You get 2 units from the capsule and 7 units from the chewable. So it's 2x plus 7y is greater than or equal to 20. So these are our restrictions. Obviously x and y, can't buy a negative amount of these. We have that. And this is what our objective function is. So let's solve all of these equations. 2y is greater than or equal to negative 8x plus 16. Divide by 2. y is greater than or equal to negative 4x plus 8. Second equation, y is greater than or equal to negative x plus 5. Well, there's not anything to do there. And lastly, 7y is greater than or equal to negative 2x plus 20. Divide by 7. You get y is greater than or equal to negative 2/7 x plus 27. Okay, so let's graph all of these. Since these are all greater thans, and these are all going to be in the first quadrant, we don't really need x is greater than or equal to 0 or y is greater than or equal to 0 in these cases. I mean, we kind of do. We'll see where. The x and y restrict us to, again, our first quadrant, the top right quadrant. Okay, y is greater than or equal to negative 4x plus 8. Start at 8. Slope of down 4 over 1. Down 4 over 1. So we've got this line. Negative x plus 5. Start at 5. Go down 1 over 1 the whole way. And then lastly, the negative 2/7 x plus 27. I'm going to have a different strategy here. I'm going to start this at, I know negative 27 plus positive 27 is 0, so if I plug in 10 for x, I'll get 0. And I'm going to go backwards, so up 2, and to the left, 1, 2, 3, 4, 5, 6, 7, and so on and so forth. 27 is a little bit less than 3, so it looks like it goes about there. Now, all of these equations are greater than equations, so that means I'm shading actually the upper area. So I have these 4 points that are in the upper area, or the corners in the upper area. We don't worry about how far it goes out, up and beyond. So we've got 0, 8. Up here, we've got 1, 4. We've got 3, 2. And we've got 10, 0. If you really want to go all in on the capsules. Okay, so let's look at the prices. At 0, 8, her cost is, it's 10x plus 20y, 10 times 0 plus 20 times 8 is 160 cents, or $1.60. At 1, 4, we've got 10 times 1 plus 20 times 4. It's 10 plus 80, which is 90, or 90 cents a day. Not bad. At 3, 2, we've got 10 times 3 plus 20 times 2. That's 30 plus 40, which is 70, so even better, 70 cents per. And lastly, we've got 10, 0. 10 times 10 plus 20 times 0 is 100, or exactly $1 per day. So if she wants to minimize her cost, she's going to pick the one with the lowest amount of money, which would be option 3 at 3, 2. So Robin minimizes cost at 70 cents per day if she buys, it's like X is capsules and Y is chewables, 3 capsules and 2 chewables. Now, you might be thinking, in what world can anyone buy 3 of one kind of multivitamin and 2 of another in those doses? More than likely, she'll get them in like doses of 100, but she'll buy 3 bottles every so often of one kind and 2 bottles of the chewables. And that's all for 7.3. It's really just word problems that are involved with 7.2. And that is the last new thing we will do for test 3.